Alright, what is a file descriptor? A file descriptor, we'll just do a links on it. File descriptor Linux. Basically, a file descriptor handles I/O redirection. Okay, and in your browser here, oh man, there's a lot of data to look through. Why is my stuff limited? And this wasn't really the best thing to do. Standard 3. You can Google for it, but here's the rundown. Okay, file descriptor is on a basic Linux system. Okay, you have three basic file descriptors, and I'm even going to say, as far as a C-based operating system goes, or in C, you have three file descriptors, and those basic file descriptors are 0, 1, and 2. Okay, standard 0 stands for standard input. Standard 1 is your output that you actually say get to the screen. Standard 2 is designated to handle any errors. Okay, now I did cat out my dev file descriptor folder, and I saw that there was 3. 3 I think is, well, I just googled it, I actually saw what 3 was. I really won't pertain to 3. I really don't think it's designated for anything. I could be 100% wrong, but I know that the 3 basic file descriptors that we need to pay attention to are 0, 1, and 2. Now, we can also hook up a, and I'm going to say, quote, imaginary file descriptor. Okay, it's not hard-coded, but we can use that to handle communications if we want to. And I'm not going to say a port, because it's really not a port. A file descriptor is taking input, output, or error and sending it somewhere. Okay, and where you send it to may be a port, but that port would be a connection to somewhere else. It's really not to deal with the internals of the file system. A port more has to deal with the networking of the file system. Okay, so if I say something like list and I hit enter, basically my standard input was list and no parameter. Okay, but what happened was it took the output, or file descriptor 1, and sent it to the screen. Okay, again, if I say list and take standard 1 and I send it to the screen, let's see here, new line. If I say take 1 and I send it to the screen, okay, that's basically what happened there. It can be assumed that when you do anything with the greater than signs, even though you can say echo into this test.txyxy, okay, even though that greater than says into something, it can be assumed that there is a file descriptor behind it. Okay, the greater than sign is actually an I/O redirect. Okay, so if you throw in the greater than sign to the computer, it may look like, take the standard output of that, okay, and put it into something. So if I say echo hi into that, and then I cat out this test.yxy, you'll see I only got hi, even though the whole command was echo hi, 1 into. Okay, because it took the standard output of that and redirected that into some file. Okay, so I can say something like list grep for cookies. Okay, now grep is set up so that if nothing is found, it really doesn't consist of an error, but at the same time, if nothing is found, don't print anything to the screen, because it's get regular expression. and if it returns nothing, or you see nothing, there was no regular expression for that. Okay? But now if I make this an error by saying list gree cookies, okay, gree is a command that's not found. However, if I take this and I will say take the standard errors and I want to put them into let's say choco.txt, you'll see that even before, when I ran this, it says gree is command not found. But now after I ran this command, nothing came to the screen. It's not that it found it, but it took the error and it put it into some file. Okay, or redirected that error into a file. So if I now say cat choco, you'll see that that contains the error. Okay, now I can in turn turn this off by saying gree cookies and take the standard error and 1. Okay, I'm going to take the error now, I'm going to put it to the screen. And there you go, it's the same as saying without anything. Okay? So, that's what we're doing. I am running screen. Let's have some fun. I'm going to say term equals screen. I have this all set up already because I failed on a tutorial. I have another box on my network that I'm going to connect to right now. Okay, this is somewhere else. It's a Mint machine. Or you name A. There it is. Okay. And over here, I'm going to set up a listener with netcat. I'm going to say netcat listen on port 5556. Okay. So netcat right now is listening on port 5556 for a connection or anything that comes in through the connection. And I'm going to say echo. I'm not going to use netcat up here. I'm going to say echo something. Okay. And I'm going to take the standard output. Okay. I didn't say 1, but I'm just going to take the standard output, which is assumed to be 1. And I'm going to put that through dev TCP, my TCP device, which is going to take a connection address of 192.168.2.201, which is my address to my listening machine, and it also takes the port, which is 5556. Okay? So I basically, without the use of any other program besides the kernel device, or the device that I compiled in my kernel, which is a TCP device, okay, I just talked to that device, which was connected to a listening machine somewhere. Okay, let me start this up again. And we can say echo something, and I'm going to take the standard output and send that, or redirect that, through my TCP device, which is connected to some port. Address and port. Same. Okay? Now, if I say, again, list, and I want to grep for, actually, let me say gree, cookie. Okay? I'm going to take that output. Oh, I have to restart my device down there. I have to take my output and send that. But, however, there was no successful output. It turned to standard error, okay, or standard 2, and instead of sending it, it actually just threw it out to the screen. So it redirected the command, took my standard in, okay, the command was bogus, and instead of sending the standard output of that, it took it and it just took the standard error and it sent that to my screen. Okay, just like that. Now if I start up my netcat listener again, do the same thing, and there it is. Okay, but now if I was to say take the standard error, okay, and only send the standard error to that listening device, you can see here that it took the standard error and sent it to my device, or it sent it through the device to my listening machine somewhere. It doesn't have to be on my network. I don't have a DNS address, but it can be anywhere. Okay, and I mean, you can connect to Google through your dev TCP device, whatever like that. You know, same. Now, one of the reasons why I showed you that is we can say something like this. I want to say echo hi into my dev TCP device, and I'm going to say irc.freenode.net. Okay? IRC, and a port. So I'll say 6667. I know that, you can Google that, but I know that because that's what I do. Okay? Now, you see we got nothing back. Now, if we take this command actually successfully executed, even though we got nothing back, our file descriptor is now closed. But if we were to say cat out file descriptor in out 1, you see, basically by just catting out file descriptor 1, whatever we type in here, it seems to be in a loop, but that's not the case. Okay, basically all it's doing is taking standard input, and when we hit enter, it's sending that standard input right to standard output. We're not actually in a loop. We didn't do any while read line, anything else like that. The only thing we're doing is we're reading from standard in, and we're directly sending it standard out. And we're sending it to standard out because we're saying here cat out file descriptor 1. Okay? But we just sent something to Freenode, but we can't communicate to them. Okay? We can't actually see what we did there, because even though we echoed hi, took our standard output, and sent it through a dev TCP device to Freenode, how can we now communicate with Freenode? We only have one-way communication. Okay? So basically file descriptor 1 is tied up. But however, file descriptor 1 was always tied up because of commands like this. Okay? List is using file descriptor 1 as well. So we have no way to actually deal with the communications coming from Freenode with file descriptor 1. And file descriptor 1 is our standard output file descriptor, or whatever was sent to the screen. We can't use file descriptor 0 because file descriptor 0 is our standard input. We can't use file descriptor 2 because that's designated for file descriptor or your errors. Whatever errors you may have, not only connecting to Freenode, but say throughout your operating system itself. So those three are tied up. But however, we can take and set up a, let's say, imaginary file descriptor, okay, and send that to Freenode. Echo hi to file descriptor 4. Okay, it's just totally arbitrary. We're going to send that to Freenode. But the machine doesn't really recognize file descriptor 4 off the bat because we're not, we didn't tell the machine that we're going to use file descriptor 4. So let's do that. Let's say exec4, okay, and we're going to say dev TCP irc.freenode, this is the address, .net, and the port number 67. Okay, we'll run that, and we can assume nothing happened. But however, if we cat out now what's coming through file descriptor 4, we can see that we actually have something that looks like a Freenode connection is initiated. Okay, even though nothing happened here. Looking up your host name, check indent, found host name, no indent response. Nothing happened here. We are actually connected to the server right now, and it's waiting for more input from us, which is this cursor blinking here. Okay. Now, when I hit Control C on that, it doesn't necessarily kill the connection, but it does terminate what's coming through. It doesn't really terminate it either. When I hit Control C, it just exits what I'm doing. If FreeNode was to say something back to us, and we catted out our file descriptor again, okay, you can see here, this is what it sent back. Okay, so that's that. In the next one, we'll talk about how to actually communicate to the server, some things we may have to throw in, some parameters, and talk to the server on its own language, and we'll keep going. Peace out.